In this video, you will learn Eclipse basics and how to safely observe with students. You will also find out how to access the required liability waiver, the permission slip, to be signed by a parent or guardian, and how the solar filtering Eclipse glasses will be distributed for the April 8th, 2024 eclipse. Any eclipse involves the blockage of light by another body, a shadow. Remember, during a lunar eclipse, you watch the moon at night. During a solar eclipse, you watch the sun during the day. A solar eclipse happens when the new moon passes directly in front of the sun as viewed from Earth. Only a tiny area on Earth is in the shadow area of a total solar eclipse. Since this area is so small, experiencing one is much more rare than a lunar eclipse. Solar eclipses are happy accidents of nature, since the apparent size of the moon and the sun are the same in our sky. The moon can perfectly cover the sun. Since you are looking at the sun in the process of being covered by the moon, most of a solar eclipse event is not safe to look at directly. Totality, when the moon is completely blocking the sun, lasts anywhere from 1 second to about 7 minutes. Totality is the only time it is safe to look with no eye protection. The entire eclipse event will last for hours. Eclipses only happen when the moon is either new or full, and only if the orbital planes are lined up. Think side view. During most of the year, the orbital planes are not lined up. The moon is usually above or below the line connecting the Earth and the sun. To get an idea of how rare it is to see one, most of North America will not be right under a total solar eclipse in the 100 years from 2000 to 2100. However, most areas will be within 1 day's drive at least once in those 100 years. The path of totality is shown here. Notice we are not in the band of the total solar eclipse. It's a 4 to 5 hour drive to get into the totality zone near Indianapolis, a bit farther if you go south to observe in southern Illinois. The center line, in green, is the geographic location with the greatest minutes of totality within the totality zone. The yellow marks the edge of totality with 1 second of total coverage of the sun. When the eclipse is total, it is safe to look at the sun. However, totality lasts for 1 second up to a few minutes. The moon never stops moving in front of the sun. In Chicagoland, we will not see totality for even 1 second. This sequence of images were taken about 20 minutes apart during a total solar eclipse. All good solar photography is done with a solar filter over the camera lens. Northern Illinois will see a partial solar eclipse just like 2017. There will not be a single moment of safe naked eye viewing. It is completely safe to be outside, but it is not okay to look directly at the sun, ever. It will get noticeably dark here, like early twilight. Bright stars and planets may be visible. Venus and Jupiter will be on opposite sides of the sun. The wind may lessen, streetlights may turn on, the temperature will probably drop, and birds will decrease or stop singing until brightening. We may even hear the chorus frogs and or spring peepers escalate their singing as if it's sunset. You might see Jupiter and Venus around 2:07 p.m. The other planets and stars may not be bright enough to be visible. This image is showing totality, more than you'll be able to see here, but the objects are in their correct locations. These photographs were taken during a solar eclipse about 15 minutes apart. 1 second is too long to stare at even a tiny bit of the surface of the sun. Remember, here in U-46, it will only be a partial solar eclipse. It is never safe to look directly at the sun, ever. Do not let students try to negotiate how long is too long. No fraction of a second is safe for direct sun viewing. Ultraviolet light from the sun is what causes sunburn on skin cells. It can also cause sunburn on the rods and cones of your retina. Rods and cones do not continually shed and replace like skin cells. A retinal burn is permanent, and if it happens while watching an eclipse, is pain-free. The pain and watering that happens when you look near or at the bright sun does not happen when most of the sun is blocked. Do not think that because you can look at the sun comfortably that it is safe. Ultraviolet energy is not felt by the eyes. It is completely safe to be outside during an eclipse, just like any other day. It is not safe to look directly at the sun during an eclipse without proper eye protection. These filters are specifically made for looking at the sun. Sunglasses do not block enough of the ultraviolet light to make it safe to look at the sun. You will receive a set of solar viewing glasses for your entire class on the day of the eclipse, April 8th, 2024, if you have completed this course. They will not be available before April 8th. They will not be available for teachers or classes that do not complete this course in its entirety. If you do not complete this course, including this entire video, you will not get the glasses to take your class outside. The filter must be between the sun and the eyes at all times while looking at the sun. More information on that coming up. There are other methods for viewing the sun that do not involve solar viewing glasses. These students are looking at an image of the sun projected to the bottom of their boxes. The sun would be up behind their backs. There is a pinhole cut in each box to let the sun's image project into the box. These are called pinhole projectors. You can make pinhole projectors with your class using the biggest cereal or similar box that you can find. Scissors, aluminum foil, tape, and a thumbtack are the only other supplies you need. Cut out both sides of the top of the cereal box and tape or glue the middle part closed. Cover one opening with aluminum foil and make a pinhole in it. With the sun at your back, align the box so the sunlight streams through the pinhole and hits the bottom of the box. White paper added to the bottom of the box adds contrast for the sun's image to appear brighter. Using it looks like this. Align the pinhole to the sun and move it around until you see the image of the sun on the bottom of the box. Remember, your back is to the sun. The downside to using a pinhole projector is that the sun's image is very small. This is not a telescope. If you make the pinhole in the foil any bigger than a pin, the image of the sun gets fuzzy and blurry. It can also be challenging to have the children get the sun behind them exactly lined up with the pinhole to actually see it in the bottom of the box. To view the sun as a whole class, a mirror projection method is recommended. You need a hand mirror and a coffee can filled with uncooked rice or sand. I set this up with the sun off to the right and the mirror aligned to reflect the sun's image onto a wall. Here is the image of the sun on a wall in the shade. An entire class of students can gather around and all look at the image together. The image could be reflected inside an open door to a flat wall or screen, like into a gym. It will be very easy for at least one class to see. I would practice it as close to 2 p.m. as possible to know exactly where to put the mirror on the day of the eclipse. The rice or sand in the coffee can is used to hold the mirror in place. Every few minutes, an adult will need to go to the mirror and adjust it to keep the image of the sun in the desired spot. Remember, the Earth is always spinning, so the reflection of the sun slowly moves along the wall. It will be totally safe to look around outside and notice the changes. It is not okay to look directly at the sun. A telescope will make a larger, more defined image of the sun on a wall, but an adult is required to stand by it continuously to ensure that no person attempts to look through the eyepiece. It is aimed at the sun and then projected on the wall through the eyepiece. It is safe to look at the image on the wall because it is a reflection of the sun, and it is easily viewed by a large group of people. It is never safe to look at the sun through a telescope. Doing so will result in catastrophic eye damage almost instantaneously. A common kitchen colander will define the sun's image sufficiently to see the eclipse through the holes. Anything with holes will work. Try a Ritz cracker, a pretzel, a straw hat, a button, or a finger lattice. Play around with distance to increase the focus. The dappled light that you can sometimes see under trees projects images of the sun in the shape of the current amount of eclipse. Have your students use a small paperclip or thumbtack to poke out their name on an index card. Don't use anything that makes the holes bigger because the projection will get blurry. They can take these cards outside during the eclipse and project tiny images of the eclipsed sun onto a white sheet of paper a few feet away. You may have to experiment a bit to find the best distance from the holy paper to the viewing paper to be the best focused. The light coming through each hole is in the current shape of the eclipsed sun. Teachers, chaperones, paras, subs, and any staff that may be outside with students must watch this video to get glasses and assist during the event. Having helpers outside with a class is recommended, especially at primary grades. The American Astronomical Society is a good source of eclipse information. Follow these instructions and check back here for new updates coming from the U-46 Science Department, all the way up to April 8th. Remember, students get their glasses on the day of the eclipse. Students and adults absent on the day of the eclipse will not get glasses. The U-46 Planetarium will be hosting free weekly eclipse programs through March up to the event on April 8th. Please know that there is a plentiful supply of misinformation and deceitful websites. It is not necessary to lock up children or panic about unknown effects of an eclipse. There are no dangerous or unknown effects on humans during a solar eclipse. The only safety hazard is looking directly at the surface of the sun without proper eye protection. It will only be partially blocked here. Even if it's cloudy, you may be able to notice darkening around 2:07 p.m., but it will be disappointing compared to a sunny day. Do an internet search for available live streams in the days before the event. There are ideas for potential activities to do in addition to a live stream in the U-46 Eclipse resource folder linked in handouts on the left. The resources and activities in this folder have been verified as reliable. Have students make a drawing of what they will expect to see during the eclipse event. A drawing then made after the event may make a good conversation starter when the before and after are compared. Thank you for watching this presentation, and let's hope for a sunny day on April 8th, 2024. Check back to this FAQ page on this Novio for updates and clarifications.